Fission and fusion seem both exothermic. Obviously, everybody has seen the hydrogen bomb, and they've also seen the fission bombs, and they both seem to produce vast amount of energy. But as you can see, fission and fusion are the opposite of one another. This seems to be a major contradiction in physics, uh, and it's actually quite an interesting one. So there are many contradictions. If you look at some of the videos that I've already put on, the charge theory is wrong, quantum is a complete madness in which miracles happen, and all kinds of other stuff. But if I take one at a time, and of course they're all, these videos are numbered, so if you can follow them, and if you're interested in order, they may make a bit more sense. But if not, you can then, at least every single video should be self-sufficient to explain the topic that it's discussing. And then if you're interested, have a look at the other ones. But in this particular one, this main contradiction in physics as to why it and the opposite of it can both be the same at the same time. That totally defies logic, because we know nothing in the universe where both black is not white at the same time, pain is not pleasure at the same time. So why does this seem to be the case? Gravity is the elephant in the room of physics, and by that I mean where gravity actually comes from. What is gravity? Gravity is bonding. I've shown you in the previous, in video 3, this is 3b, continuing from that, where gravity comes from and what it basically is. If you haven't seen this, it might be worth a quick recap before we go ahead. All atoms are basically rearrangements of the hydrogen atom. If you look at it, there's a proton, electrons. If you look more at helium, protons. Remember, neutrons are manufactured from fusion. They're not distinct particles. They are just modified protons. In fact, they may not even be modified protons, because they look like they have been bonded here by the electrons, or a part of the electron that was used in here. So it's like a covalent bonding of the protons in here. So essentially you've got a proton nucleus and electrons on the outside, and if you go to oxygen and even bigger atoms like sodium and so on and so forth, all you have is a protonic center and electrons around it. So essentially you're basically looking at the same pattern repeating itself in a fractal way, which is what this universe is. It's just the similar patterns repeating over and over again. And since, say for example, a piece of rock is made up of these atoms and various other compounds that are made from these atoms, then essentially this piece of rock is nothing but it's some of its protons and the sum of its electrons. And essentially, since the Earth is then made up of all of these things and rocks, the Earth is nothing but the sum of its protons and the sum of its electrons. That applies the same to the Sun, and it applies to the black hole at the center of our galaxy. So essentially what you have is what I call the electron slope food chain. It's all about relativity. So what that means is that if you look at a rock and you look at the Earth, the rock has a much smaller population of protons. Therefore, that then becomes the proton relative to it, and it will try to suck out the electrons that are on there by attacking it. And the same applies to the Sun. That's why then it goes into an orbit like the Moon. And we are in an orbit around the Sun, which is the center proton. Here, look at it again. Just exactly the same as the relationship between an electron and a proton in a hydrogen atom repeats itself over and over again. So relative to the Earth, the Sun is a giant proton, and we are relative to it a giant electron, meaning the food chain. If you look at the Serengeti later on, and you'll go into evolution and life itself, food is nothing but the chasing of electrons. So if you have less electrons compared to another animal, then you are the predator. It is your prey. And the same applies to grass and herbivores. The grass is electron rich relative to it. That's why it eats it, and so on and so forth. So why does gravity squash? This is important. If you look at two hydrogen atoms, and by the way, many of the other inconsistencies, especially charge theory, which has remained like muddy boots from the electric days, is completely wrong. Opposites do not attract. They, in fact, opposites trap. The proton traps the electron, which just wants to be moving in a straight line and away from it. That's why it enters into an orbit. And electrons are supposed to repel one another, and protons, positive charges, supposed to repel one another. But in the hydrogen atom here, if you look at it, the hydrogen molecule is the preferred state. In other words, it wants to be together. Why? Despite two negative events, meaning if the electrons repelled one another, you could never have bonding. That's impossible. Electrons do not repel one another. They only repel one another if the direction of the motion is opposing. If they're both moving in the same direction, they actually combine, they show interference pattern, and they increase in intensity. So the idea of negatives repelling one another is completely wrong. But here I show you just a visual idea of what's happening. If you have two trapeze artists hanging from the ceiling with two ropes, they grab each other's arms and pull. And that's like two protons pulling on each other's electrons, you get the squashing effect. And that's where the squashing effect of the gravity comes in. Now, if you imagine, here are the force vectors where they're going. No matter how many populations you add to this nucleus here, or the anchor as I call it, because it becomes spatially anchored and it doesn't move anymore, and everything else then congregates around it, all of the vectors will increasingly be directed towards that center. And the center becomes the most compact point, if you like, and where the gravity is the greatest. So all the force vectors are additive, meaning that basically whatever event you're looking at, whether it's the moon, whether it's a rock, whether it's the sun, its gravitational field, or the force field that it has, is basically the sum of all the protonic force fields, and they all are additive, and the electrons also become additive. So relative speaking, here you have the relative food chain. A bigger body is a predator relative to a smaller one, and on it goes. So that would be the rock, that would be planet Earth, that would be the sun, and this would be the black hole. And the relationship is identical to the relationship between an electron and the proton, because they're all made up of the same thing, and that is what you should expect it to be, because anything else is ridiculous. So just to show you here what I mean, what I said before, is if you look at the hydrogen atom here, the most logical thing to think about a proton is to think about it as a force field, that it actually gets less and less as you go away from the center. There may not be anything solid in the center, it's just a force field. The idea of particles, I think, is completely misleading. It's just a force field. So essentially, what you would have is the center of proton there, and say where 4 is there, you might have a normal electron in the hydrogen atom, but then the 6th will be the excited state of the hydrogen atom. So when you add more photons to it, the electron jumps into a higher orbit, and then when it releases the energy, it falls back into that position. So here we don't really consider there to be any space. There is no space. It's just the proton itself is there. Now, if you add all of the protons, and I'm showing you this in a bigger, here's the sun sitting at the front, here's the Earth as one of the electrons type of relationship here. But look at Pluto. It's 40 times even further out than planet Earth. So essentially what you are looking at is the idea, I've tackled this within another video with Einstein about space. Space does not exist. Space is gravity. So our perception that there are gaps between all of these things is just the human mind making a mistake. But essentially, as you can see, the gravitational field, just like the hydrogen proton here, or the protonic field, if you like, of the sun, extend all the way out to Pluto, and perhaps even further out. It overlaps other things. And certainly the protonic field, or the force field, of the black star at the center of the galaxy stretches way beyond this galaxy and interferes with other galaxies. So space it does not exist, because space in its true sense implies nothing, and nothing cannot exist. That's just a logical fallacy. So space is gravity. So violation of a conservation law. Fission and fusion are both exothermic. So does gravity create energy? Because that's what it implies. How does gravity take an electron, which is what I just said to you before? Everything is made up of the hydrogen atom, and turns it into a gamma ray, millions of times more energy rich. That implies that it actually must create energy. But to look at that even more simplistically before we start, is to ask the question, how does gravity accelerate an event? Does it inject energy into the system, or motion waves into the system? And the answer is, well, of course not, because it doesn't have energy, unless you're some quantum genius and you can come up with nonsense like gravitons or some other crap. The answer is no, it doesn't. Why not? Because the effect is the same. You can either make something accelerate like this by putting more and more energy into it and it goes away, or you can drop it in a gravitational field and it will accelerate, and the results will be almost, you know, identical. So why not? Why does gravity accelerate a thing? And why is there terminal velocity? So the answer to this problem is in this terminal velocity thing, because there seems to be a limit to which gravity can accelerate events. Now, it's misleading in some ways that if you look at it in an event like the Earth has an atmosphere, and those molecules in the air will act as a drag force. So if you drop an apple, for example, its weight will balance at a point with the drag of the molecules and the resistance that they provide, like a cushion under it, and then there will be a terminal velocity. But that's misleading, because the terminal velocity will exist even if there is no air in the system, or there is no drag force, and that's an interesting question I'll get to. So the major flaw in physics must be addressed, and that is, almost no physicist, or I've never seen one, can explain how a photon, which doesn't have mass, induces motion into an event, because it doesn't have momentum. So how does it make a thing move? And without resorting to mathematical mumbo jumbo, none of them can actually give you a simple, straightforward physical or an image that you can easily understand. So, excuse me. Here you have a proton, and again, let's take the simplest example of all of the events, which is the hydrogen atom. Here's an electron. If a photon comes along, what does it do? How does it move this proton and accelerate it? And the answer is, I've said in the other video, is simply this. If you can think about the orbitals when they are motionless and sitting still as a hydrogen, it will be a circular motion. More or less, it doesn't really matter. But my point is that when you accelerate it, you twist the orbital bond in this direction of the motion, wherever you are accelerating it to. In other words, the accelerating energy, going back to that, this photon will hit that electronic field here, because electrons are not particles, they're all over the place. I've shown you in another one. It's like a cloud all the way around the proton, and it combines with it and gradually deforms it in that direction of motion. So what you have then is, this diagram is not very good, I'm sorry, but I think you can still see what I mean. Is there's the proton. If you keep adding units of motion or photons to it, eventually what you do is there's first resistance to acceleration, which is what mass is, and then eventually you start to get this distortion in the direction of motion until you accelerate the event. So my point is that the orbital electrons are deformed in the direction of motion. So terminal velocity is reached because gravity does not inject any new energy into the system when it's accelerating it. The force simply sucks out the existing energy in the bonding orbitals and distorts them in the direction of the center of mass, which is a perfectly normal thing to do. So, and I've shown you the mechanism just before. So for any given gravitational field, and here's the interesting bit, it is almost certainly true that this distortion force will be finite. It cannot distort it indefinitely and keep accelerating it, because that bond will not break. Or in fact, it may, because if you have an event where the event is bonded together with different molecules and compounds, this gravitational acceleration might actually rip it apart. But still, there will be a limit to how much that gravitational field can accelerate it, so you get a terminal velocity. Now, going from there, acceleration under gravity cannot inject extra energy into the system. It distorts the bonding energies to reduce the energy available for periodicity. So what does that mean? That's in one of the other videos I showed you that time doesn't exist, and Einstein's wrong in the experiment that was done when sending a clock into space in a jet. It didn't do anything to time, it did something to the atoms. Now, all atoms have periodicities, rotation and vibration energies. When you distort the bonding orbitals in the direction, if you think about it as an elastic, if you're pulling it in one way, there's less elasticity than available for the rotation and vibration energies. So therefore, the periodicities of those events, the atoms in the clock stop vibrating and rotating or doing whatever they were doing as fast as before, because there's less energy available, and that shows the dilation of time, which is complete nonsense. There is no time. It's just the dilation of periodicities. So how are high energy photons created by gravity from just electrons? And that's the interesting part. So when you look at it here, for example, you have increasing frequencies as you're going along, and the higher the frequency, the more the energy. So how does it take just a simple electron and turn it into these, without violating the conservation laws? Like I said, if you look, the mechanism for gravity is that it squashes things together, and all of the vectors then keep pushing towards the center of gravity, and that's where the pressure is the highest, or the lattice pressure of the system. And what that really basically does is that as it squashes everything, you can imagine, think of a photon as a spring. That's all it is. It's like a spring, and it just squashes that spring. That's what gravity does. So it alienates its own energy by the protons pulling on each other, kind of electrons, if you know what I mean. It's basically alienating the energy of the photon itself, and compressing it, just like a spring. So when inside the lattice pressure increases and the photons become compressed, when liberated, they relax back to the normal frequency. So no energy was put in, so no energy is created or lost. In this particular scenario, gravity is renormalized. In other words, the thing expands. So is the opposite of compression. Now it's expanding, no energy was used, no energy is required in this particular case. So there's no violation of the laws. It's just like compressing a spring and then letting it come back. So why is there such a huge amount of heat released when a fission or fusion bomb goes off? Heat is proportional to the frequency of collisions, and that's how we, feel it, the number of collisions on your skin. The higher the frequency of the photon, the higher the collision, in terms of simple statistics. So basically, the difference between fission and fusion, which one is actually exothermic? Well, the answer is the fusion is not exothermic. Fusion is endothermic in a weird kind of way, because it uses the squashing nature of gravity by alienating the electronic force here, as I've shown you the mechanism, to compress everything and then release some energy as it comes out. But if you want to repeat this, you're going to have to inject an enormous amount of energy first to compress everything, to replicate, if you like, the effect of gravity, and that is an endothermic thing to do. So you need to put in a lot of energy, and that's why when they make the hydrogen bombs, they have to use a fusion bomb to first compress the damn thing before it can be, before it can release its high energy photons. So in the normal sense of the word, fission is the real exothermic one, where the energy of not the energy, it's the wrong word, where the compression, the lattice compression of gravity has compressed the photons, and basically when it expands again, it creates a wave, if you like, of reactions, a chain reaction that releases an enormous amount of energy. So in real terms, fusion is endothermic in that respect. So fusion energy at room temperature is the major question. This free thing that we've been dreaming about, that one day we can just get fusion energy at room temperature. I don't think so. I mean, if you look at the principles that are involved, you're going to need to replicate gravity, and you cannot replicate gravity quite simply in a normal way. You're going to have to compress something with an enormous amount of energy to go from an electron or a low energy photon into these gamma rays and beyond. So in the absence of gravity, you need a huge amount of compression energy, because the electron doesn't really want to be anywhere near the proton. It's constantly, like a bird that is trapped, is constantly trying to run away, and that's why it's entered into an orbit. And as it gets more and more energy, it goes further and further out, but then it releases some energy and falls back when it gets tired, if you like. So anyway, if you need a more complete and systematic explanation of the points raised in these videos, then this book is available free of charge. I don't want anything from you from a Kindle ebook. It's called Cosmonomy, and it might help you, to have a look and make up your own mind and see what is right. Anyway, thanks.